So today we are coming to continue with our matrix lectureship we are going with. Yesterday, or the other video, the first video was the introduction to matrix. Today we are coming to go a little bit deep into the matrix. So today, the matrix, what we'll be dealing with, we'll be talking about the operators, how we can use the mathematical operators such as the minus, the plus, and the multiplication. Today we will come and use these operators in our matrix. So we talk about, for example, we are having a matrix A, example. Let's say we have A as a matrix equal 1, 2, maybe 4. We can have 3 minus 2 minus 4. And we also have matrix B to be equals to, let's say, 7, 9, 3, minus 1, minus 1, 2. And the question can be like, let's find matrix C which equals to A plus B. So the operator we are coming to discuss is that we are to discuss about the operator addition of what? Of matrix. Addition of matrix, basically, this is the concept. It's just like the normal addition that we learned in our basic level. Maybe 2 plus 2 equals to 4. The same thing, if we add matrix A plus matrix B, we should get a matrix called what? C. So now let's see how we add matrix. So to add matrix, you pick the row, add to the next matrix row. Then you come and pick the second row. Let's say this is 3 by 3, a 2 by 3 matrix. In terms of dimension, it has 2 elements in row and 3 elements in column. So we call it 3 by 3, 2 by 3 matrix. So you say, okay, this is A. In place of this A, we put 1, 2, 4, 3 minus 2 minus 4 plus 7, 9, 3, neck 1, 2 equal to C. So to add matrix, you always pick your row. This is your first matrix. Matrix A is your first matrix. Matrix B is your second matrix. So you pick the first row. Let's say first, second row, and what? Third row. So let's come here. You have the first row for this at the second matrix side. Have the second row. We have at the third row as well. So you pick the first row, add to the first row of the second matrix. So you'll be 1. We'll go with 7. 1 plus 7. Then you also have 3 plus minus 1. So the summation of this and this will give you 1 element in the matrix. So then you also pick the second row, add to the second row of this matrix. So you have 2 plus 9, negative 2 plus negative 1. Now you now pick the third row, add to what? The third row. So you have 4 plus 3 minus 4 plus 2 equals to matrix C. So now 1 plus 7 will get 8. Now 2 plus 9 we get 11. Now we have 4 plus 3 you get 7. 2 plus minus 1, you get 2. Minus 2 plus minus 1, you get minus 3. Minus 4 plus 2, you get minus 2 equals to 2. So in addition of matrix, the key thing you need to note is that if they are even 1000 row respect to some number of columns, you pick the first row, add to the second matrix row in that order till you are done with your addition. So basically this is how we add matrix. You pick your first row matrix, add to the second matrix first row in that, like just mapping. So let's take our second example. Example 2. We can have a matrix D to be equals to 2, 3, 4, 7, 1, like 1. We have a matrix G to be equals to 1, 4, 5, 6, 8, and 9. Then the question can say find H which equals D plus G. Find H equals D plus D what? Matrix. So it means we're adding matrix D to matrix what? G to help us get a matrix called H. So say H matrix will be equals to D. So we have 2, 3, 4, 7, 1, minus 1. Plus 1, 4, 8, 5, 6, 9. So in terms of rule, we're having rule element of 3. In terms of column, we have element of what? 2, making up what? The column. So you say H matrix will be equals to 3. This row, the first row, plus what? The first row of the second matrix. The second row of the first matrix to the second row of the second matrix. So you have 2 added to 1 and 7 adding up to 5. So we pick 3, it goes with 4. So 3 go with 4, then 1 go with 6. So 1 plus 6. Then we have 4 go with 8, then minus 1 will go with 9. So now 3, 2 plus 1, we have 3. 7 plus 5, we have 12. Now we have 3 plus 4, we'll get 7. We have 1 plus 6, we have 7 there. 4 plus 8, we'll get 12. Then minus 9 plus minus 1 plus 9, we get 8. So 8 matrix equals to 3, 7, 12, 12, 7, 8. So in addition of matrix, you pick a row, go with row. First row will go with the second additional row. Then you pick the second row of the matrix to the other one. So if it is 5 by 5 matrix, you pick the first row to the in that order till all the rows have been what? Added. Now let's quickly look into when we're also dealing with subtraction. The second operator we'll learn today is the subtraction operator. Subtraction. Subtraction of matrix. So let's talk about the subtraction of matrix. So how do we subtract matrix mathematically? So we say, let's consider matrix called Z. Z as a matrix is equals to three minus 3 and minus 4, 3. And B equals neg 1, 2, neg 2, 3. And they are saying maybe determine D equals Z minus B. So find matrix D. So to find matrix D, or to determine the matrix called D, then you need to subtract matrix Z, B from what? Z. So we say matrix D, which equals Z minus B. D will be equals to 3 minus 3 minus 4, 3 minus 1, 2 minus 2, 3. So when you come to the minus, it is the minus and then the addition are almost the same. The minus and the addition are always the same. You pick the row, subtract from what? The row. You pick the row, subtract from what? The row. So to get D, D will be equals to, you pick your first row. This is our first row. This is called the second row. So when you come to the matrix B, you have its first row to be this, and its second row to be this, right? So now, we pick the first row, subtract the first element from what? You pick this first element, subtract from the first element of your first row, and the second element of the second row, subtract it from what? The second element of the first row. Basically, let's just put it on board. We have 3 minus 1. So this will subtract from that. So you also pick this, subtract from this. Then you have minus 3 minus 2. So now let's get here. So we have minus 4 minus 2. Then 3 minus 3. So minus will give us positive. Then that means 3 is now adding to what? 1. Then you get 4. Then minus 2, minus 3 minus 2 gives us minus 5. Let's come to the second column. We have minus 4 minus 2. So we get what? Minus will give us positive 2. So minus 4 is now plus 2, which will give us negative 2. Then positive 3 plus positive 3 minus 3 will give us 0. Then means the matrix D now equals to 4 minus 2, negative 5 and 0. So as the explanation goes, subtraction and then the addition, you just need to pick your row minus the second matrix row. You pick the second row minus what? The second matrix row. Then you add it. But you need to note, let's observe something. In matrix, the subtraction and the addition of matrix is only possible for the case of equal matrix. It's possible for only equal matrix. That means that the first matrix, let's say matrix A, 8 column, matrix A, the number of columns must be equal to matrix B, which it is to add to the number of columns in the row. So what I'm saying is that, let's take A for example. If A has a matrix of 1, 2, 4, 3, minus 2, minus 4, and matrix B equals 7, 9, 3, minus 1, minus 1, 3. And they're asking us to say y equals A minus B, or y equals A plus B. Because see, the number of elements that make up the columns is 3. The number of elements that make up the row is 2. We come to matrix B, the number of elements that make up the column is what? 3 elements. So here elements, column element C is what? 3. Row element R equals to what? 2. When we come here, column element equals to 3. Row element R equals to what? 2. That is only possible for minus and what? Plus. But let's say the case of this. A matrix A have changed. A now equals to 1, 2, 3. Then we have 0, 0, 1, 2. Then we have B equals to 1, 2, 3, 4, 5 and 8, and 9, 3 and 1, negative 1. In terms of column for matrix A is 3. In terms of row R, column C is 3, row R is equals to 2. But when you come to matrix B, column C equals to 3, but row R equals to 3. Now let's see whether we can find, let's say D. D equals to A plus B. I want to prove to you that in matrix, unless the number of columns and the rows are equal for both matrices before the addition and subtraction is possible. But now if this one, see the number of rows is 2, but here is 3. Now columns are the same. Let's see whether it's possible to add or subtract. Now let's see. This is matrix A. This is matrix B. Now let's see whether we can find matrix D1 here. Now when you pick row and bring it here, then you have 1. So this row will add to this row. So that means that 1 plus 1. Now 0 plus 1. So 1 plus 1, so now this one was 0 plus 1, so 0 or 1 plus 0. Now, 3 don't have a matching element here. So, it means that you cannot add matrix B and matrix what? A together. Because the number of rows here is not equal to the number of rows here. And the rule is saying that you add the row to a row. So this one is longer than this, so it can what? Fix in. So in matrix, the moment they give you a question to analyze matrix in terms of addition and minusing, you should make sure that the matrix have equal number of rows. The number of rows in the first matrix must be equal to the number of rows in the second matrix. The number of columns in the first matrix should be also equal to the number of columns. Before addition and then minusing will be what? Possible. Due to this theory, they will say that okay, addition of matrix is commutative. One, it is commutative. Two, we can say addition of matrix is also what? Associative. That is to say, it is A plus B equals B plus A. What it means is that if we have matrix A to be 1, 3, 4, 5, 6, and minus 3. Minus matrix B will be equals to minus 2 minus 1, 4 minus 5, 2 minus 3. Let's prove whether this is possible. So it means wherever we see A, we put this matrix there. Wherever we see B, we put this matrix there. When you come to the left side, the right side and the left side, we do the same. So we have A plus B to be equals to B plus A to prove whether addition is associative or commutative. So we say, okay, 1, 3, 4, 5, 6 minus 3 plus minus 2 minus 1, 4 minus 3, 2 minus 3 should be equals to minus 2 minus 1, 5 minus 2 minus 3 should be plus with 1, 3, 4, 5, 6, and minus 3. So what we want to say is that when we add this and this, we add this and this, you should get the element, the first element should be equal to the summation. When you sum this and this, whatever element value you get, it should be the same as when you add this and this together. So let's prove and see. It means, as the theory says, row to row. So the row there we say 1 plus minus 2. 1 plus the minus 2 over there. Then 5 plus the minus 1. 5 plus minus 1. Now, we come to the second column, or the second row with the second row. Second row first with this. So that means we are now getting 3 plus 4, then 6 plus minus 5. Then we get to the 4, we'll add 2. 2 to 4 plus 2. The minus 3 go with minus 3. Minus 3 plus minus 3. And this will be equal to, when we come to this side too. So let's analyze this side and see what do we have. 1 plus minus 2 gives us minus 1. 5 plus minus 2 gives us 3. Get a 3 plus 4 gives us 7. 6 plus minus 5 gives us 1. 4 plus 2 gives us 6. Minus 3 plus minus 3 will give us minus 6. That is our left side operation. So this result stands in for the A plus B. So let's see whether A plus B will be equals to B plus A. So let's pick B plus A. B plus A will also equals to, which is down here, which is 1, 5, 3, 4, 6 minus 3. And our A is plus to 1, 3, 4, 5, 6 minus 3. So 1 will be added to 1. So we have 1 plus 1. 5 will go with the other 5 here.